Hello, welcome to the Mechanical Engineering webinar from Carnegie Mellon University's Career and Professional Development Center. My name is Jeff Jeffries. I'm the Director of Employer Relations for the CPDC. And today we are going to discuss the, here, I'll let you do this. We're going to do, here's our agenda. Today we're going to do a little introduction. And we have Satbir Singh here. He's Associate Professor with our Mechanical Engineering Department. We also have Mark Badilian. He's Associate Professor with Mechanical Engineering as well. And they are going to talk to you about our different programs, the curriculum, the coursework, and the types of degrees, and how they get involved with our Mechanical Engineering Department. And then after that, we're going to do a little wrap-up and talk about some of our fall recruiting events that we have going on. And then we'll do a little Q&A. But just a little bit, I want to tell you a little bit about the Mechanical Engineering Department here. We have, obviously, it's a fantastic program, consistently ranked in the top 10. A lot of different employers from different industries come here, from product design, aerospace, energy, oil and gas, healthcare, robotics, automotive, banking and consulting, and of course tech. And then we also have several student organizations that you as employers can really tap into and really help build some relationships there. So over here we put a few of those student organizations that you can build relationships with to really tap into the students from mechanical engineering and have those relationships with them. But something that's really exciting that's happening here on campus, we have our TechSpark makerspace that is going to be growing with the ANSYS Hall that we're building, so that is going to become larger. And I believe that will be completed here sometime in this year, in 2019. So that's something to keep an eye out for as well. And if it's something when you're on campus and if you want to have a look at that, please let us know, and we can certainly make that happen. But to get things started, we're going to have Satbir go first. So Satbir, I'm going to turn it over to you.
Hi, so I'm a faculty in the Mechanical Engineering Department. I work very closely with the master's program. So what I'm going to do today is spend a few minutes talking about introducing you the master's program in the Mechanical Engineering Department. So what this slide shows is that we have a large pool of MS students that the companies can recruit from. In a given academic year, we have close to 250 master's students compared to our bachelor students, which are above 400 here. The PhD program is also big size, which is about 130 to 140 students, depending on the year. What I will be talking about from here onwards is only the master's program. So we want to look at the graduation schedule for the students. About 70 to 75% of our master's students graduate in May, so they just graduated this weekend, about 70 to 75. And about 50 to 60 of our master's students graduate in December. So that's just to keep in mind when it comes to recruitment, how many of the students will be available for you to recruit from, depending on which time of the year it is. If you look at the demographics of our master's students, and this is only master's students, anywhere from 25 to 30% is domestic U.S. national students, and about 70 to 75% is international students. This particular pie chart is for F-18 enrollment, but those are our typical numbers between domestic and international. Our program is highly selective. This is data that I'm showing here from fall 18 applications, but it's a typical data. We get about 700 applications from all over the world, and we admit only 1/3 of those, and about 50% of those who are admitted enroll. So it's a highly wanted and selective program, and we have a high quality of students coming into the program. We have students coming from top schools from US, and also from all over the world, especially from India and China. Here I'm comparing test scores of our master's students with the PhD students. As you can see, they are pretty competitive. Our PhD program is even more selective. So this chart here, bar chart, just shows you that our master's students are as good as our PhD students. And the scores here are TOEFL score, which is a speaking score. International students have to take the TOEFL exam to come to the US before they can be admitted. So that's, we have pretty good English communication quality among our applicants, and also the GRE scores are also good. So we have very high quality input coming into the master's program. We offer 3 master's degrees within the Department of Mechanical Engineering. The first degree is our 2-semester degree. It's a course-based degree. It's called Master of Science in Mechanical Engineering. It's popular among our own undergraduates. So CMU undergraduates, if their GPA is above 3.0, they can automatically be admitted into this program. So this is a program that's more popular among them. Then last semester, in fall 18, we started a new course-based degree. This is going to be called Master of Science in Mechanical Engineering - Advanced Study. This is again a course-based degree, but it's 3 semesters long. So this degree, in curriculum-wise, it's more structured. Each student has to declare a technical concentration in one of the mechanical engineering discipline. They have to take professional development courses. They have to take project-based courses. So this degree is substantially differentiated from the other degree, and it's a longer degree, so the students have to take more courses in this degree. Then we have a very typical MS research degree. You will find this degree at many other schools also. It's a 2-year degree. Students have to do research over a period of 2 years. They have to write a research report and present in our research symposium. So you can see that the 50% of our master's students are in the research-based degree, and about 50% of them are in 2 course-based degree options. And the students choose whatever fits them according to their needs. So what I would like to do is that we have strong quality input coming in, and I want to just focus on key strengths of our curriculum that we have here at CMU. First of all, interdisciplinary research. CMU is known for interdisciplinary research, and mechanical engineering department is a big part of that. We have research in many different areas. I've just highlighted a few areas here: robotics and controls, data science and mechanical engineering, additive manufacturing. The point that I want to convey here is that over 60% of close to 60% of our students in the master's program are interested in robotics and controls. So they are developing skill sets related to robotics and controls, and about 40% of students are spread across other disciplines of mechanical engineering. Another point to take away from here is that over 80% of our students are looking for jobs after graduation, and only about 15 to 20% actually go for PhD. So you have a large pool of very good quality candidates to recruit from in May and also in December. We have a balance between engineering and computer science exposure. As you may all know, CMU is very well known for computer science. Our curriculum allows our students to get a strong exposure to mechanical engineering, but also an added exposure to computer science. So I show a pie chart here of courses taken by master's students. 2/3 of the courses were taken within the mechanical engineering department, 1/3 outside MECI. And some of them are College of Engineering, COE, and other here means mostly computer science. So other means all over Carnegie Mellon campus, but I will tell you that 90% of those are in computer science and robotics. So we have very strong balance between mechanical engineering fundamental being augmented by courses from School of Computer Science. We also provide our students real-world problem solving and project-based courses. So the students who are working on research, and about 100 students are involved in research, they are getting this experience in the research lab. But even the students who are in course-based degree options, we have developed over the past 4 to 5 years, we have developed 13 project-based courses within the Department of Mechanical Engineering, and students have access to courses in other departments also. So what is a project-based course? In a project-based course, students have to work on team-based projects. At least 50% of the grade comes based on the project. They have to spend at least 50% of their time in the semester on the project. They have to be involved in professional development elements, such as they have to write reports, they have to give oral presentations, and they have to give poster presentations. So we think this is really unique about our courses here in the mechanical engineering department, that we have a significant number of project-based courses in all areas of mechanical engineering. So project-based courses, some of them will be computational and some of them will be actually hands-on. So I want to touch on hands-on experience. Undergraduate students get their hands-on experience from their capstone courses. It is not very common to have graduate level courses with hands-on experiences, but we have intentionally created graduate level courses which provide students hands-on experience. And I give you few options here, from manufacturing to robotics. We have examples of robotic design and experimentation, graduate level course, Internet of Robotic Things, and modern manufacturing in Steel Town. So this is another aspect of the graduate curriculum that we provide hands-on experiences. Even if you are in a course-based degree option, you're going to get more hands-on experience from these courses that you would get at other schools. We have a number of courses that are at the intersection of engineering, computations, and data science. And I counted these courses. Currently, we have somewhere between 12 to 14 courses in the mechanical engineering department, which we are calling them at the intersection of engineering and computations. Here I'm giving you an example of one course which is called Computational Analysis of Transport Phenomena. This is an example of a project from that course, but we have many different types of courses in this area. We also have courses at the intersection of engineering and data science. This is an example of a course from our own faculty in the mechanical engineering department, which is at the intersection of mechanical engineering and machine learning. We currently have 3 graduate courses of this type in our department, and that's because we have 3 faculty in our department in the mechanical engineering who are working at the intersection of engineering and machine learning. We're going to have 2 more courses in next year, so you'll have 5 courses which will be combining machine learning tools and techniques to mechanical engineering. So this is again a strength of our department, which is not easy to find in other mechanical engineering departments. I want to touch on the last key point here. Strength of our curriculum is professional development. So one of our degree requires students to take at least one professional development course. These courses are open to all students, all master's students. One degree requires it, but other students in other degrees are also taking these courses. Within the mechanical engineering department, we have developed our own professional development course. Some of these courses are taught by our local industry folks as adjunct faculty. For example, mechanical engineering project management course is taught by somebody who works at a local company here. We also work with the university level resources. And one example I want to give is we have CMU has a center called Global Communication Center. It's called GCC. They come to our courses and help us, our instructors implement professional development elements into courses. And this is spread all among courses. This is there in all project-based courses, and we have 12 of them. We are developing students in report writing in English, in oral communications, in poster presentation, project management, team conflict management. So all of these elements are implemented into these project-based courses. Another thing that we have done is we have collaborated with some companies here to work with us in our courses. These are logos of few companies who have contributed projects to our project-based courses. And for this audience here today, you are also welcome to work with us, to partner with us in this area and in many other areas. So we have high-quality students coming in from top schools with top scores. We are highly selective. We have a very strong curriculum for them, and the outcomes are very good. As you can see, most of our students are employed when they graduate. Some of them go for PhD. So the outcomes are very strong. So the message here is we have high-quality output coming from our program, and we would strongly encourage you to engage with our department, engage with our university to recruit mechanical engineering master's students. The last slide here is some ideas on how to get involved. If you would like to get involved with us, you can contribute projects to our research labs, to our courses, project-based courses. You can participate in design reviews, attend career fairs, hold info sessions, provide internships to our students. That's the best way to actually recruit students, and also provide job shadowing opportunities. So this is the end of the presentation for the master's program.
Terrific. And we're going to pass it over to Mark, and Mark is going to talk about our undergraduate program.
All right, thanks. I want to start off by just talking about who we are, and I know Sapir already mentioned some of this, but we have a diverse student body. So currently we have 421 students. That's sophomore through senior year. Our freshmen are counted differently. And so that is a fairly large size program. One of the things we're proud about with this student body is that it is diverse. So 33% are female, that is high relative to our peers, and 27.8% come from underrepresented minorities. We are also a strong community, so our students are engaged. They're active outside of the classroom, and I have a list of some of the activities that students are involved in: ASME, Pi Tau Sigma, Women in MECI. They're also involved, which we'll talk a little bit more about later, in some co-curricular activities that build some other skills. And they also are active as alumni, and you can see a few pictures of our students out in the community interacting with people and helping spread the word about mechanical engineering. We have a flexible program that also has a solid set of fundamentals. So one of the unique features that we have is that we have students who have a very broad background. For instance, a third of our students pursue a double major, so that's a really high number, and those students typically graduate in 4 years, provided that they come in with some advanced placement credits. We have a quarter of our students pursuing a minor, which is also a high number. And the way this has all come about is that 15% of the units or credits in the program can come from elective courses. So if I break this down and look at where are these double majors coming from, you can see that the pie is dominated really by 3 elements. The biggest is biomedical engineering, which 48% of our double majors take as their second major, and followed by robotics and engineering and public policy, which are pretty close together. We have some other majors, computer science, physics. Those are typically a little bit harder to get. The curriculum is structured such that it is relatively easy to get these double majors in those particular categories. On the minor front, we have minors in 31 different programs, and those really span the board. So the double majors are largely in technical topics, as you can see, but we have minors in music or sound design or technical writing or linguistics. So these students have a really broad background, and I think that's one of the things that sets our program apart is the breadth of experience our students get coming out. Now, going back to the hands-on aspect, we have this maker culture that Jeff mentioned in the beginning that we're trying to grow, and we're trying to spread these capabilities as they come online throughout the undergraduate curriculum. So what you can see is classes from the freshman through the senior year, and there are 2 different colors of classes. The colors in red are the core courses, which are required for students, and the courses in gray are the courses that are electives that many students choose to take. And you can see that in every year, students are required to have experiences that include hands-on activities. Now, some of them you would expect. For instance, we have our capstone design courses in the senior year, where naturally students are going to be making prototypes, but we've also put this into courses that are maybe not so obvious. For instance, stress analysis in the sophomore year has a project where students fabricate a crane and test it for strength. You can also see that many of these elective courses have them using skills outside of just machining. So obviously our students know how to machine, but they're also developing their electronics and computation skills in courses such as gadgetry to help them be more well-rounded as mechanical engineers. As we develop this curriculum, so obviously we're changing our curriculum to add more of the hands-on component, but another thing we try to do is assess where is mechanical engineering going and how can we improve our program to adapt to the changes in society. So we assess our program continuously, analyze the outcomes, and then try to respond. And I just have a listing, a short listing of courses that were recently added to the program or are about to be added. We've added a scientific computing course where students learn the fundamentals of MATLAB. We've added linear algebra into our math curriculum to help students be better prepared, for instance, in courses in controls or in machine learning, which is a unique course that we're having for undergraduate students starting next year. We also have our mechatronics-based courses, which are coming into the curriculum. And I want to highlight just one of these, and that is the machine learning for undergraduates. So we're trying to get our students involved in data science and looking at trends that are happening throughout society. And so our students in this course will learn about neural networks, and they'll be applying statistics to draw inferences from data sets. And you can see this is a very popular class, and CMU is well known for this in computer science, but mechanical engineering, as Sapir mentioned, we also have expertise in this space. So we have a class, at the bottom there that is showing just how popular it is. There are not enough seats for our machine learning course in mechanical engineering. We also have a very strong co-curricular experience. As I said, our students are highly engaged. And in these co-curricular experiences, they're building leadership, they're developing teamwork skills, they're learning about project management and technical real-world problem solving, all outside of the curriculum, but working with faculty advisors and working with company sponsors in order to do this. So I just want to highlight a few. Carnegie Mellon Racing came in first place in 2 different competitions in the 2018 Formula SAE electric vehicle competition and the Formula North competition for the electric vehicle. CMU Rocket Command, a relatively recent club who had their first competition in 2018, immediately started with a top 10 finish. They came in first place in the altitude competition. We also have a solar racing team that is building a solar boat right now. So those are the sort of clubs that students get involved at. We're also highly involved in undergraduate research. So about 50% of our students have an undergraduate research experience before they graduate. Many of them are involved throughout their entire undergraduate career, freshman through senior. We also have students build project portfolios along the way. And one of our unique features is we have flexible capstone course paths. So many schools have a single capstone course that everyone takes. We have flexibility in capstone. So some people take an engineering design 2 course, which focuses on entrepreneurship. Some take electromechanical systems design, which is mechatronics. We also have robotics capstone, biomedical engineering design project. All of these count towards our mechanical engineering capstone requirement. And we have a variety of projects in these courses. Some of them are student initiated, which allows students to explore all the way from customer requirements and ideation all the way through the prototyping phase. And some of them are company driven, where you might become more involved, where we try to foster student-client interaction in developing these projects. And after a bachelor's degree, we see a bit of a diverse path. And in fact, there are really 2 forks in the road. We have about 50% of our students go on to continuing education, and I'll say about 30% of those students are going on to CMU's integrated bachelor's program, which would be included in Sapir's numbers. And we have about 50% that go into employment. They go into various different industries, from finance to robotics, and they have varying different titles. So robotic software engineer, hardware engineer, some of them you would expect, some of them you would not necessarily expect, like a software engineer coming out of mechanical engineering. In continuing education, you see the usual suspects. Our students go to top schools to pursue PhDs or master's degrees. And how can you get involved? One of the things we really want to focus on at the undergraduate level is developing or improving our co-op program. We've had some difficulties. While we are flexible, we've had some sequencing roadblocks for students, so we want to try to improve our opportunities. I would say about 95% of students take an internship, and only about 5% of students currently do a co-op, but we are improving that pathway. So if there's somewhere that would be great to get people involved in, it's developing co-ops that our students might apply to. Sponsoring class projects, as Sapir said, the capstone level would be great. We also have a machine design course that takes company-sponsored projects. We also have a great number of design reviews and presentations where students would love to get feedback, and of course, attending career fairs to interact with our students and recruit them for either full-time employment or these co-ops and internships would be a great way to get involved. Now I'll pass this back to Jeff to wrap.
Great. All right. Thanks, Mark. Thanks, Sapir. Yeah, so what we want to do real quick, we'll get into a little Q&A session here. I just wanted to show you our 2019 fall schedule so everybody knows what to expect there. I'm not going to go through everything here due to time constraints, but if you want to access this information, you can feel free to reach out to me directly. It's also on the CPDC website where you can access our schedule for fall. And again, we use Handshake, so if you want to do anything like schedule career fairs, on-campus interviews, post jobs, please go through our Handshake platform. And as Mark and Sapir mentioned, if you do wish to get involved with any co-ops, capstones, anything like that, if you want to get more involved, feel free to reach out to me, and I'm happy to help point you in the right direction to make sure that can happen within our mechanical engineering department. But at this point, let's open it up for Q&A. Are there any questions out there?
So far, no, but let's give them a couple seconds or a minute or so to. Yeah, we did in the chat. Yep, please feel free to submit your questions in the chat. Got a good showing. We have about 45 people listening. Okay, great. This one's from Jennifer. Do employers need to sign an agreement with the school for co-op purposes?
That's something I'm not too sure about. Maybe you know at the Career Center level.
So for co-ops, we would, I would have you talk to Matt Bartman. He would be able to walk you through that. There are some things with co-ops that there might be some sort of agreement that one would need to sign, but that's a great question. But and Matt unfortunately is not here. But if you do have some questions, you feel free to forward them to me, and we can get those answered for you.
Great. Any other questions? Okay, we got one here. Whoop. All right, they're coming in quick now. Okay, for on-campus recruiting efforts in the fall, how early should we reach out to the CPDC and the Mechanical Engineering Department?
You can start reaching out right now for fall recruiting. We are open for that. If you go through Handshake, you can start scheduling your events that you want to do, whether it be info sessions or career fairs, or if you just want to come on site to do some interviewing in our Career Center, you're welcome to do that through Handshake.
Great. Another one is, how would we get in contact with Matt Bartman?
Matt Bartman, if you send me an email and my contact information's in there, I will forward that information on to Matt.
The other one is from Ryan Jip. Can you please share this slide set? And we will be sharing the slides and webinar on our website in the near future. So we will definitely be sure to share that information. The next is from Jessica. Is it possible to repost the slide that shows the student organizations? Yep, we can go back that way. Is it?
It's up near the front. It's up near the front.
Oh, it's up near the front. Okay.
It should be the third slide.
Yeah, forward a bit.
Good. Mine, okay.
Okay, I got to go all the way up to the front. Yep. I think.
I had one that had all the organizations.
Yeah, that's what Jeff has the slide in the beginning. Here we go. It's going to be right here.
There it goes.
Yep, if you look on the bottom right. Okay, the next is, do you have any recommendations on better advertising or increasing attendance to events or info sessions?
So, yeah, I think if you're looking to promote your info sessions, one of the things that you should do is work through us here at the CPDC, but also within the Mechanical Engineering Department. We at CPDC and Melissa can work with students directly. We also have career consultants that work directly with students in mechanical engineering. So typically if you pass that stuff on to us, those events, we get them out to our career consultants and Melissa, who can get those out to the students. And then also the student organizations, if you do some outreach directly to them, we have a website called The Bridge, and if you don't have the link to that, it is on our website as well, the CPDC website, but that will connect you to all the different student organizations and will give you the direct contacts for the presidents of each one of those student orgs. And if you are coming to campus, you can help market those through us, but also if you want to let those student organizations know directly, you can certainly go through that route as well, and it's a great way to connect with those student orgs and let them know that you're going to be on campus for an event.
For undergraduate students, what are their future interests? Seems like robotics and biomed are most popular. What about traditional manufacturing design?
We definitely have students that are involved in design. I would say they have a breadth of interest, certainly robotics and controls and that side, just like in the master's program, those are popular topics with our students, but we have students that are interested in thermodynamics, we have students interested in classical solid mechanics. I would say we have a broad spectrum of students. Maybe, I don't know, maybe 40% are interested in sort of the robotics and control side, but that leaves 60% to spread among the rest. So there's plenty that are interested in machine design, for instance.
Great. From Sarah, just for a rough estimate, how much coding are ME students exposed to?
Is this for undergraduates or?
It looks like either undergraduate or master's.
So for master's program, the students who are here for a period of 3 semesters, I think you could say they would take anywhere from 2 to 3, at least 2 to 3 CS-related coding courses. So 1 semester at least for the master's students on an average.
On the undergraduate side, all of our students have to take a semester-long course in Python, which is programming fundamentals. They also take a numerical methods course, which is taught in MATLAB. And they also have to take a MATLAB course that teaches the fundamentals of MATLAB. They do not necessarily see exposure to C, although they have plenty of elective courses that would expose them to C as well. And many of them take additional courses out of the computer science department to improve their skills beyond that.
Great. I wanted to clarify, because when Jeff said to email him about Matt Bartman, this is his email right up here so that you can see who you're emailing for that information as it comes to Matt Bartman. Another one is, do you have a similar info on PhD students and their research areas?
So we don't have a slide deck for the PhD students, and the reason we did not present PhD students here was that PhD students usually specialize in a very special topic, research that they're working with, and the job seeking experience of PhD students is very different compared to master's and undergraduate students. So we will have 160 PhD students on campus this fall, total in the department, and they are spread across all areas. So mechanical engineering at CMU, we have 30 full-time faculty, and they're all spread across different areas. So I don't have a short answer. I don't have a slide deck for PhD students, but our PhD students are specializing in all areas of mechanical engineering. So I wouldn't be able to say 50% of them are robotics. It's not like that. I think that 60% number of robotics that I said is more applicable to master's students. For PhD students, they work with the faculty member. Our faculty members are spread across all areas, so they have all kinds of PhD students.
Yeah, makes sense.
So our last question looks like, are any student design reviews presentations web-based?
Not right now, although that's an interesting suggestion and something we could think about. Right now they are all in person, but we certainly have the facilities to change that, and that's something we can consider.
Any last questions, or if not, we'll wrap it up.
None. Any other questions? Give it a minute here.
Give it another couple seconds, yeah.
Okay. If there's nothing else.
We got one more.
Oh, wait.
Do students take any technical writing courses as part of their curriculum?
So the master's students are not required to take courses, but the master's students in the advanced study degree, which is this 3-semester course-based degree, are required to take 2 project-based courses. And in each project-based courses, they are required to go through at least one written report, and at least one oral presentation. So it's happening organically in these courses, but it's not required in the sense that they don't have to take one required course. But they do have to take the professional development course, which might have some writing components, some oral presentation, some project management, and all of that.
Research students have to write a paper.
Our research students have to write a research paper also. So it's not a course, but they're getting the experiences. On the undergraduate side, Mark?
On the undergrad side, they do have to take a technical writing course. They also take a course on technical presentations.
Okay,
Great.
Terrific.
Okay, well, that's where we're going to end it today. Thank you so much for spending the last half hour with us. If you have any questions, please feel free to reach out to Jeff, as you can see on the slide deck showing currently, or you can reach out to us through his phone number as well. I want to thank our folks over from the Mechanical Engineering Department for joining us, and we look forward to working with you in the coming year. Thank you.
Thank you.
Thanks.